Now, when we talk about any communication in networking, security is what very important uh, because it is fast, because it is physical topology independent. We cannot simply jump into SD-WAN uh, without knowing about security that it guarantees. We all know that IPsec is one of the options that SD-WAN provides over the tunnel between WAN edge to WAN edge, between sites. But we know about IPsec, traditional IPsec environment. Key exchange is handled by IKE protocol. In phase 1, the IKE protocol, the endpoints communicate about how to establish a secure tunnel. Likewise, in IKE phase 2, they communicate about how to secure the data tunnel. So we have a phase 1 tunnel in which we establish how to establish a secure tunnel. In phase 2 tunnel, how to secure data inside the tunnel is communicated and established. So in traditional IPsec, we see a lot of key exchange needed to authenticate the devices. Because of that, the traditional IPsec is not scalable. It does not scale in a large network. You might have come across DMVPN. Again, DMVPN is better than site to site because you don't need to create multiple tunnels for each spokes, agreed, but complexity is growing, like NHS, NHRP, multicast, packet router to the spokes device, and so on. So IK means IPsec is good, but the traditional IPsec environment exchanges a lot of keys, lots of keys, which is not a scalable IPsec. So what they have done is in SD-WAN they made IPsec to work differently. SD-WAN provides a scalable solution to data plane key exchange, which is going to do device authentication. So in SD-WAN, the keys are distributed via the control plane infrastructure, not the data plane. Repeating again. In SD-WAN, the keys are distributed via control plane infrastructure. What comes in your mind when I say control plane infrastructure? Just finished components of SD-WAN. When I say control plane infrastructure, what comes in your mind? Can anyone answer this? Within SD-WAN, keys are distributed via control plane infrastructure. not the data plane. What does that mean? What do you understand from that? Why long silent? Mhm. Okay, you're close but not really. Yes, vSmart. Control plane infrastructure. That's vManager is NMS, management plane. It's an orchestration plane. Sorry, orchestrator is vBond. That's a management plane. vManager is management plane. So, thank you. So in SD-WAN, the keys are distributed via the OMP protocol. That is also part of what? Control plane infrastructure. Whenever OMP comes into picture, obviously the vSmart will come into picture. So in simple, we can say the keys are distributed via vSmart, not by the WAN edge. Point to be noted. In traditional IPsec VPN, who distributes the key? It's the edge devices, the site edge devices. But here, the site edge device, we call it as what? Data plane. Data plane can generate the key, but the distribution of key is done by the control plane only. And who is the control plane? vSmart. And what is the protocol that's going to take the key from the data plane to the control plane? OMP. It's well-known story, no? But very big difference we are seeing here. The keys are not distributed by the edge device. Traditional IPsec VPN, they generate the key, they distribute the key, but here the keys are distributed by the control plane. So every WAN edge router advertises its local IPsec encryption key. If you have one MPLS connection, if you have one IPsec connection, sorry, IP internet connection, for each transport, the key will be generated and advertised using OMP. The vSmart controller supplements. So vSmart controller uses those keys to protect the data plane traffic. Now, how is this scalable? How this is scalable? One is we already know the answer. OMP is already running between all the WAN edges and the vSmart. So when we give it to that vSmart, it distributes to all other WAN, not all WAN edges. It distributes the key to all those WAN edges to which the communication is allowed. If WAN edge 5 and WAN edge 10 is not allowed to communicate, the keys of WAN edge 5 won't be given to WAN edge 10. So we can see that vSmart knows the policy, the control plane policy from the vManage. With the knowledge, it knows to whom the key need to be exchanged, not to everyone. So this is one reason for scalability from a centralized smart device. It is given. Secondly, see, there is no need for phase one. In traditional IPsec, we have phase one, and this phase one is to discuss how we are going to establish a secure tunnel. Correct? In traditional IPsec, phase one is to discuss how we are going to establish a secure tunnel. But in SD-WAN, that is not needed. Why it's not needed? We already have TLS, DTLS connection, peering, secure peering established between the vSmart and the WAN edges. So, because the WAN edge router and vSmart have got already a secure tunnel, TLS, DTLS, through which the OMP is already running. OMP peering is already done between the vSmart and the V edges. Because the control plane and the data plane is already having secure tunnel, there is no need for phase one IKE. Each WAN edge router periodically generates AES key. Those who have done yep. See, phase one is to negotiate. The phase one key exchange in traditional IPsec is to discuss how we are going to have a secured tunnel. How we are going to establish a secure tunnel discussion is what we usually see in phase one conversation, phase one IKE, phase one conversation. How we are going to establish a secure tunnel. But in SD-WAN, before IPsec, we already have a secure tunnel established. Before IPsec, we already have a secure tunnel between the WAN edge and vSmart. Between all the edges and vSmart, we already have a secure tunnel. What is that secure tunnel? TLS. With some component device, we have DTLS. With some, we have TLS. Between vSmart and vManage, we have TLS secured connection. Between the WAN edge and the vSmart, we have DTLS. With the controller, so with the orchestrator also, we have DTLS, UDP based. We have already a secure tunnel. Because the WAN edge router and vSmart has have a secure tunnel, there is no need for IKE phase one. But IKE phase one periodically generates a key, and a rekey happens every 24 hours. No, every 1 hour. That you need to check. IPsec. I think it is 1 hour. Rekeying happens every 1 hour in phase one. In phase two, every 24 hours. This may be 100% right, or there may be a timer difference, and you need to check that. I forgot. But there is a rekey in phase one. When we don't use phase one in SD-WAN, are we compromising with that quality? No. Here also, we are going to have keys regenerated periodically. The difference is here AES key is going to be regenerated. AES is phase 2, data plane encryption protocol for encrypting the data plane traffic. We use AES. AES SHA-HMAC for integrity, AES DES or triple DES. So we still have that periodic generation of key, and it is going to be AES key for its data path. Now, I already told you for each transport there is going to be a separate key generated by the data plane. Yes, we have one key per T-log. One key per T-log. And then WAN edge router transmits this key to the vSmart controller, as we all spoke earlier. The vSmart controller, the control plane. In OMP route packet. OMP determines the control plane, right? The route. In the OMP route packet, the WAN edge router transmits the keys to the vSmart controller. So every WAN edge router advertises a local IPsec encryption key as one of the T-log attribute in OMP. Let me repeat. We are not learning something big here. We already know there is a TLS connection between WAN edge and vSmart. We already know there is a protocol OMP, which is very important for the control plane to come up for the path determination as per the policy between the WAN edge sites. We need OMP, we already know. So OMP will have a lot of route attributes. We call it as T-log attributes. It is only the T-log attributes. No. Sorry. Yeah, this is what I'm talking. Thank you. Right, I just finished only up to these 2 points. Now we are in this point. Thank you for reminding me. So it is OMP protocol that ensures the propagation of encryption key, which will be used by the data plane. So vSmart controller takes care of the IPsec key distribution or AES key distribution. Now we are using the SD-WAN control plane so that AES keys for all the WAN edge routers are distributed across the network, which is the scalable way. Yeah. So we are using the SD-WAN control plane to distribute the AES key, which is periodically generated. Also, WAN edge router allows the key only for those WAN edge routers that are allowed to communicate. Very important point. We already saw this point. Like keys are not given to every WAN edge routers. No, key of site 1 may be given to site 4 and 5 because between site 1, 4, and 5, communication is allowed. Other sites don't get the key. Yeah? So this is also another reason for scalability. So WAN edge router learns the key only for those WAN edge routers that they are allowed to communicate with. In traditional network, the control plane is handled by the routing and switching protocol. Yeah. Control plane is handled by routing and switching protocol. But those routing protocols, they are only to provide the route information, how the packet to be routed to the destination. They don't offer any mechanism to authenticate a device. Or they don't do encrypt they don't encrypt the control information, the routing information. Repeating again. I'm trying to explain this point. In our traditional network, the control planes are handled by the routing protocol, both in routing as well as switching. The control planes are handled by routing and switching protocol. If you take STP, that is the control plane protocol for layer 2. BGP, OSPF, EIGRP, RIP, ISIS, these are all the control plane protocol that is building the routing table that maintains the packet the direction of the packet to go to reach the destination. In this control plane, the traditional control plane, we have very few authentication, but again, there is not a mechanism to authenticate a device, or they don't have option to encrypt the control information. Whereas the SD-WAN control plane is based on DTLS or TLS. So every tunnel is going to be TLS or DTLS. Whether you have IPsec or not, you see you are already protected. All the communication is private between the SD-WAN devices. See, to become a part of SD-WAN, they have to undergo this TLS, DTLS. Every device, WAN Edge, vSmart, vBond, vManage. First of all, they are going to get authenticated using certificates, whitelist model. We are going to see that as the next topic. So, after getting authenticated, after the devices got authenticated by this control plane, only then they become part of SD-WAN. So this DTLS and TLS already provides, it is already providing a privacy on all its channel. So every SD-WAN components, the devices, They already use very secure communication. Now, after IPsec, they use AES encryption algorithm for encryption of all control plane traffic sent over the connection. For authentication, we are using a digital certificate. And also, DTLS TLS connection uses protocol like SHA-1 or SHA-2 to provide the guaranteed or to ensure the integrity, to make sure that the informations are not tampered. See, so we got digital certificate, we got TLS DTLS connections with SHA-1 or 2, which provides the guaranteed integrity. That's the job of this SHA-1, SHA-2. Now, about the certificate. The certificates are installed by the software or hard-coded into the hardware. Depends on the device role in the SD-WAN network. Every device need to have certificate. Every device need to get authenticated. Some device it's software, some device it's hardware. So the role of certificate is to identify the device and allow the device themselves to automatically determine to which network they belong to. So we saw AES providing keys, and we saw that every single device gets authenticated by the control plane. Even the control plane informations are encrypted in SD-WAN, which was lagging in a traditional network. So, as I said, the certificates are important. We have zero trust principle. What does that mean? Zero trust principle. That means that only the authenticated, authorized device are allowed to access and participate in SD-WAN overall network. Zero trust principle. So only authenticated and authorized device are allowed to access SD-WAN or allowed to participate in SD-WAN overlay network. So every component in SD-WAN authenticates each other. So vSmart controller performs an automatic authentication on the authorization of all WAN edge router before they allow to participate in SD-WAN overlay. So vSmart also authenticates. It's not only vBond, but it is, as we all know, vBond is the one which brings the WAN edges on board. But that is not the only level in which authentication happens. Every single device will authenticate the other devices to make sure that they belong to this common overlay fabric. So vSmart controller performs automatic authentication and authorization of every WAN edge router before they are allowed to participate in this overlay, SD-WAN overlay, and have the ability to send any traffic over the network. So it checks whether the authentication and authorizations are valid. So how this automatic authentication or authorization by the vSmart is conducted with the help of certificates and whitelist. Yep. So as I already said, it is not only vBond that brings the device on board by authenticating. That is initially vBond authenticates all WAN edge devices that comes on board. Now later, for the control plane, for the overlay SD-WAN membership, an authentication and authorization is also needed, and it is conducted by vSmart. Now, the vEdge routers, Cisco's Websela Edge router. The vEdge router has the security with a factory installed chip. The chip is going to hold the signature, the signed certificate. In vEdge router, the signed certificate is a factory installed chip. The chip is called as TPM. 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 This is the name of the chip. So this helps to authenticate the newly added vEdge routers to join the SD-WAN overlay. So every WAN edge router is uniquely identified with the chassis ID, certificate, and the serial number. And the certificate is there in TPM clip. Serial number, obviously, it is there in the box. Chassis is also there, hard coded. So the SD-WAN component must use the combination of certificate and this whitelist mechanism like serial number, chassis ID, and so on. So the first element of authentication process is that we need to carry out to ensure the components are actually a Cisco box. That's very important. So to know that a Cisco box is trying to participate, the manufacturer does the authentication process with the help of the embedded certificate in TPM chip, the chassis number, and the serial number. So that will guarantee that, okay, this is a Cisco device. So before controllers can be operational in SD-WAN overlay, each controller must have both a root certificate plus the controller certificate, which is signed and installed. See, if you are from the security background, you will know what is a root certificate. Root certificates are the one which is signed by the root CA server, not the subordinate CAs. I don't want to get into security track. We have a separate security track where I teach PKI and all the CA certificate hierarchies. So the identity of WAN router is also done with root certificate. So root certificate can be preloaded by the manufacturer in the TPM chip. You can also load manually and distributed automatically by the vManage. And these are installed during a PNP process, which we have not covered it. PNP and the ZTP provisioning process. So if the certificate is not loaded, the authentication process is going to fail. And when it comes up, it won't be able to participate in SD-WAN overlay network. So this pre-signed certificate is what Cisco uses, and it is kept in what TPM chip, the WAN edge router. Right. So this is what about the authentication, authorization of SD-WAN. See how securely each component in SD-WAN is identified and enrolled into the SD-WAN. So what we have seen today is the control plane takes responsibility of distributing the AES keys using OMP. Every WAN edge device generates key. As a route attribute, it is distributed to the vSmart, and vSmart only distributes to all, not all, to the WAN edges that are allowed by policy to communicate. So when a WAN edge device receives a key, it receives only from those edge routers to which it is allowed to communicate. So before all this IPsec happens, they already authenticate and they establish a tunnel using TLS and DTLS. So there is no need for phase 1 IPsec. There is no need for phase 1. Because every component in SD-WAN are already authenticated. They are authenticated using the root certificate, using the serial number, using the chassis number, which is manually uploaded to vManage, which is also embedded in every VEdge switches, the chip called TPM, that helps to have a zero trust principle. So about the certificates and whitelist model, zero touch principle, we are going to learn in depth in coming classes. So this chapter was about the control plane and data plane security. For every single transport, there is a separate key generated by the data plane device, advertised to vSmart. Any question about the control plane data plane security, you may ask. All right. If no